Hi guys, welcome to this tutorial on creating a faux gravity system within Unity. So this basically enables us to have characters that can walk around on spheres or other such surfaces. This is what we'll be creating over the course of the tutorial. And this system will work for any sort of game, whether it's top-down, first-person, third-person, or any other kind of view that you can imagine. So let's get right into a new Unity file and start coding this. So in Blender I've created a very simple planet model, if you can even call it that. It's just a sphere with a bunch of cubes sort of scattered around it just to act as points of reference. And I'm going to drag this into my Unity project. And I'm just going to organize things a little bit by creating a models folder into which I'll put the planet. And we'll keep this automatically generated materials folder, and I'll call this material here planet. I'll duplicate it and call this rocks. We can just pretend that those little cubes on the planet are rocks, and I'll center the planet in my scene. And going into my camera, first of all I'm just going to change the background color to black, and then I'm also going to drag this out just so we can see the whole planet in our view. And we need some lights in our scene, so I'm going to create a directional light, and I'm just going to call this the sun. And since it's the sun, I'll give it a bit of a yellowy tinge, something like that. And if you've got Unity Pro, then you can turn on some shadows just for fun. And let's assign these materials, so the planet onto the planet and the rocks onto the little cubes. And we'll just set these to some basic colors, nice brown and maybe a dark gray for the rocks. Yeah, just something like that. And I'm also going to create a capsule, and this will be our player model for now. Oops, I'm going to just put it at 0, 25 and 0. And let's create the scripts that we're going to be using now. So in the assets folder, right click, create new folder, and I'll call this scripts. And it's in here that we'll have our 3 C# scripts. So the first 2, which are essential for the actual gravity setup, are the Faux Gravity tractor and the Faux Gravity body. And the last script that we'll have is just some sort of, oops, not a boo script, a C# script. This will just be some sort of player controller so we can move our player around and test it. So the Faux Gravity attractor is what's going to be applied to the planet itself, and it will basically attract all the Faux Gravity bodies. And the Faux Gravity bodies basically just tell the Faux Gravity attractor to attract them. That's all that they do. So on the planet, let's just add this Faux Gravity attractor script, and we also want to add a sphere collider. And at the same time I'm going to go into my rocks and add a mesh collider, just so that we can't walk through them. And our capsule, which we can rename player, will have a Faux Gravity body and of course the player controller script. And the Faux Gravity body basically just needs a reference to the attractor. So Faux Gravity attractor, and in its update method it's basically just going to say attractor.attract my transform. So in the start method we'll just set up a private transform my transform, which we'll just set to transform. The reason why we do this is just it's a tiny bit of optimization. It's not very important. You could just put in transform there, but whenever I'm using transform a lot, I'll actually just create a little reference to it. And in the start method as well, we just want to say rigid body, because we'll have a rigid body to detect the collisions. Rigid body dot constraints is equal to rigid body, this time with a capital R, rigid body constraints dot freeze rotation, and we also want to say rigid body dot use gravity equals false, because all of, well, these two things, the rotation and the gravity, those are going to be controlled by the attract method in the attractor. So let's go to the attractor script, and this will just have a public void attract, which, as we saw, will take in a transform body, and we'll have all of the attraction code in there, but we just need a public float gravity, and I'll set this to -10 by default. So let's go into the player quickly, and let's see what's going on here. Did I save this? No, I don't think I did. That's the problem. There's now a slot for our tractor, so our tractor is the planet, and I'll just drag that in there. And we're basically completely finished with this Faux Gravity body script. So everything else is going to be happening within this attract method. So the first thing that we want to do is we want to figure out the direction of the player from the center of the planet. So we can do this by just saying vector3, and we'll call this gravity up. This is the up direction of gravity, and it's equal to the position of the body, so that's body.position, minus the position of the planet, transform.position, and we'll just normalize this value by just saying .normalized. And for later on, let's just create a vector3 local up, or maybe this is better called body up, and this is just equal to body.up. So that's the direction that the body is currently facing. So we always want the body to be facing gravity up, so we'll be sort of moving from the body up to gravity up. So let's first of all add a force to the body's rigid body, making it always head towards the planet. So we can say body.rigid body dot add force, and the force that we want to add is just gravity up times gravity. So that will just be adding a force in the direction from the center of the planet to the player. And now we want to deal with the rotation. So let's create a quaternion, which we'll call target rotation. And we want to figure out the rotation between two directions, the gravity up and the body up. So we can say quaternion dot from to rotation, and you can see this takes in two directions, the from direction and the to direction. And our from direction is the body up, and the to direction, well, we want to go to gravity up. And this will basically give us the difference between these. Well, the sort of rotation between these is probably a better way to describe it. And we want to add onto that the body's current rotation, and with a quaternion we can do this just by multiplying the body's current rotation. So now we want to make the body's rotation move towards this target rotation smoothly. So we can say body.rotation is equal to quaternion dot slurp, which is basically lerp but spherical interpolation. And we want to go from the body's current rotation to the target rotation, and we'll just pass in some speed here, say 50 multiplied by time.delta time. And that's really all the code that we'll need. Let's just press play. And we're getting a null reference exception. Let's see what that's about. Oh, we need to add our rigid body to the player. Just forgot about that for a moment. Add rigid body. And that should work. So this falls down to the ground, and you can see if we move it over here, it continues to, well, to work, as you'd expect, I guess. And now all that remains is for us to set up a basic player controller so we can actually properly test this out. So all we really need to do is create a public float, we call this move speed, and I'll set this to 15 maybe. And we need a private vector 3 for our move direction. And in the update method, I'll just set the move direction to a new vector 3. And for the x, I'll just say input.getAxisRaw horizontal, 0 on the y, and for the z, just input.getAxisRaw vertical. Okay, so we're getting some basic directional input there. And at the end of this, I'll just add .normalized. And now, since this is a rigid body that we're moving, we want to do the moving code inside of fixed update as opposed to just update. And in here, we'll use the rigidbody.movePosition method. And it takes, well, we need to give it the new position that we want to move to. So first of all, we can get our current position, rigidbody.position, and we want to add in our amount that we want to move. So that's obviously move direction times move speed, and we also want to multiply this by time.delta time. But the only problem here is that rigidbody.movePosition will move it in world space, and we want this to be in local space so that it moves with the curvature of the planet. So the way we can convert this into local space is by saying transform with a small t dot transform direction, and we can just put move direction into those brackets, parentheses. And now let's play. And things are working. So just to get a better view of things, I'm just going to parent my main camera to the player. And I'll just make it look down on the player. It would be better to create some sort of camera follow script, but not going to bother with that for now. Maybe 20 is a good value. And yeah, you can see we have the same setup that I showed at the beginning of the video, so that's pretty much mission accomplished. So if you've got any questions, just leave a comment, and it's also worth noting that you can download the entire project file from a link in the video description. I guess that's everything, so I hope you've enjoyed the video, and I'll see you next time. Cheers.